Building Science 101 is sponsored by Anderson Windows and Doors, Builder's First Source, Huber Engineered Woods, Polyguard, Sashco, and ViewRail.
All right, my friends, Building Science 101, Part 3, the building science of both comfort and health. Where do we start, Steve?
Wow, that's a loaded one, right? We talked about building shelter and why do we build, and it's to gain control. Well, even though we talk about things like durability and energy efficiency, what people really acknowledge is comfort.
Yeah.
Right? They wouldn't know when they walk in the house either, wow, it's hot in here or it's cold in here. They never say, hey, there's water in my walls, or I hear the walls leaking. They don't know that. But they can immediately identify with temperature, humidity, and comfort issues.
Yeah.
Health, that's a little bit trickier.
Yeah, that's a little harder.
But, comfort, let's get after it. We'll talk about comfort first. I'm just going to get us started here. So, comfort and health. They're both pretty much, I think, tied together, that if we solve for one, you basically solve for the other one pretty much.
For sure.
Right? But, the whole idea of comfort is, again, I want to be somewhere in here when it's either 100 out here or it's 0 out here.
Mm-hmm.
I want it to be 70 in here. And I grab my nice little architect-y building section here because that's the one that really helps identify that we have these boundary systems across the house that even at the ground, when it's 70 in there, it might be 55 here on the ground. And so those boundaries are really, providing that shelter, that enclosure, and the ability to get control inside there. Now, comfort to me, it's pretty much a two-headed monster, right? There's the issues of, hey, it's outside in Arizona or it's outside in Minnesota,
Mm-hmm.
right? So we have to climate tune our buildings and the assemblies to where we're located.
Yeah.
Climate tuning is a relatively new concept, but I like it. It's a real quick one to identify. I tell people when I'm lecturing that, if I'm going to New Orleans, I pack a certain type of clothing.
Mm-hmm.
I don't pack the same clothing if I'm going to Montana
That's right.
in February. It's a totally different. So if I'm building in Montana, or I'm building in New Orleans, or I'm building in Des Moines, Iowa, chances are I have 3 different sets of clothing.
Hey, we need to tune that clothing for the environment.
And for everybody, it's going to be different. So we're really trying to kind of tune a range, because you might want to stay in a house where it's 70 degrees. I might like it a little cooler at 68 degrees to sleep. So, but we need to be able to tune that inside. But to do that, we have to get our first understanding of what's happening outside. And a lot of builders and a lot of architects don't really understand that concept. You can go across the country and some of them are just, we build a 2x6 wall with plywood and building paper. And that's our standard wall wherever we build. And they never really question it.
Yeah.
The second part is tuning the equipment to the house. I mean, I'm sure you've had tons of experience down here where you walk into a modestly sized house and on your way in or driving by, you see 3 condensing units outside.
Mm-hmm.
And you hear, hey, this house has got 6 tons of cooling. And you're like, but it's 2,400 square feet. Why?
Why is the engine so big that's needed to make this house cool in the summertime?
Yeah. And if we did our job on that first part of comfort and tuning it to the climate, then tuning the equipment should be a pretty easy process.
Yeah.
Right? Because we typically, in my case anyways, I over-tune the project to the site.
Mm-hmm.
So that means we can kind of underscore the tuning of the equipment that actually goes into the house.
Let me break down one thing that you mentioned, Steve. You mentioned that comfort is a two-headed monster. So, Steve, if you take a look at that drawing of yours and we think about comfort, how do most people tune their houses after the house is built for comfort? Well, it's a thermostat on the wall. And we try to place those thermostats in a spot that's usually like that that middle wall, let's say, that's in between spaces where there's no direct sunlight hitting that thermostat, but that thermostat really only has one readout. It has the temperature on there. But in fact, our bodies have so many receptors for comfort. I've heard Robert Bean talk about this before, and he says that we've got like 1 million receptors for comfort on our body.
Yep.
And the other thing that we need to remember is that humidity factors into comfort as well. So just because that thermostat on the wall says 70 degrees, let's say, that doesn't necessarily mean that you're comfortable in the house. You might have an elevated humidity. You might be sitting in an area where you've got direct sunlight on you. You have all these other factors that relate to comfort besides just what that thermostat setting says.
Yeah, I mean, humidity certainly plays a role. I spent a lot of time in both New Orleans and New Mexico, and given the same temperature, different humidity.
Oh, yeah.
New Orleans, I don't understand why people would want to live out there. Shit, nothing against you all that live in New Orleans, but man, you go there for a 4th of July party.
It is humid.
No, it's HELL all the way.
Yeah.
But the beauty of New Mexico is it can be 95 degrees, but it's such a dry air that the moisture just evaporates off your skin and you don't feel that discomfort that you would, say, in Houston or New Orleans.
It's funny you mentioned that, Steve. Yesterday, when you and I were getting prepped for this, I was looking at my little Apple weather device, right? My Apple Weather app that said the temperature outside was 97 and sunny yesterday here in Austin, Texas. But it feels like, as a typical button you see on this, it said it felt like 104. Well, the humidity outside was 48%, and the dew point was 73 degrees. We're backtracking a little bit on the durability side, but as we talked about in the last episode, if that air were to leak in and find a surface on the house that would be 73 degrees or colder, we could have condensation happening there. But the other thing that this reminded me of is, gosh, when it's really humid and hot, it's even more uncomfortable. So 97 is already hot, but it felt like 104 yesterday because of that elevated humidity. And so as we get control for our buildings, and now as we move from control to actually comfort and health, this really plays a part. That humidity, and especially elevated humidity, is going to play a big part in making both a comfortable house and a house that's not going to have indoor air quality issues. Because remember, when we get to elevated humidity in our houses, we also have a lot more opportunity for other types of things to grow in the house, whether that's mold growth, whether that's dust mite activity. There's all kinds of things that happen and get elevated as humidity gets above 60% relative humidity.
Yeah, and I've often heard it's really interesting that people can identify temperature a lot easier than they can identify relative humidity. But it's inversely proportional in that I hate sweating more than I hate being hot.
That's true. That's a good point.
Right? So it's like I can't really identify it, but I can walk into a house and say, oh my God, this is awful.
Yeah.
Right. And it could be just that high humidity. So comfort, we're tuning that house to the location. But now, because we built that environment inside, we've taken or attempted to take control, we have to get the right equipment and tune that. And that not only means just the equipment we purchase, right? We want to make sure that the registers are potentially in the right location. They're delivering the right amount of air so that we can supply that comfort. And, the residential industry here, you guys are fortunate. You have Christoph and his crew right down the street here. But, up in New England, we pretty much have to go out of state to get somebody that really understands residential. I mean, there's a lot of engineers, office buildings and stuff, they have that down. But when especially if you're building a well-tuned house, I had one client where it was actually this house, right? So we designed it and they sent it out to the HVAC guy, and the HVAC guy comes back and he had, I don't know, some load, 70,000 BTUs or something crazy. And the homeowner's like, Steve, we designed, we all these months, this house is crazy. He says we need like 4 or 5 tons of cooling in this. And I was like, no, he's not getting it. And so the tuning part is you have to tune the equipment, but the equations to get you there, that person that's punching in those numbers really needs to understand what those numbers mean.
Yeah, that's right.
And this person didn't. I took that same set of drawings, same set of specs, gave them to another gentleman that knows what he was doing, and he came back at like 17,000.
Oh my gosh. Wow.
Right? So almost 25%. And here's the reality. We ended up putting 3 mini splits on the wall here. One of them he never has used. Right? So
he's
the
still out.
guy that I
50% more.
trusted, where we have 30% more of the heating inside the house.
That's
so
crazy.
it can be done, but we just really need to understand. And it's truly a collaborative effort. As an architect, you just can't sit there and say, okay, guys, hey, here's the drawings, Mr. Builder, go build this house. He turns it over to his HVAC guy and says, hey, whip up a quick ductwork. That guy sends it off to his supply house. They run a manual J. They never even looked at what kind of windows are we using? What type of air leakage spec
Yeah.
are we talking about for this house? None of that. They kind of have their rule of thumb.
Yeah. We should actually back up and we define what a manual J is for
So a manual
listeners who don't know.
J is the calculations that size the ductwork.
It's basically a sizing calculation by sometimes an engineer, sometimes a trained person, where they basically input all the exterior walls and tell this computer program, I have this many square feet of walls facing this direction, let's say west, that's going to catch the west sun, this many square feet of walls facing this direction, and oh, by the way, here's the level of insulation, here's the level of air tightness, here's all the data on the windows, including the windows sizes, so they know how much glass, because in general, windows are much less efficient than walls. And then they input all that data into a computer that spits out, okay, here's how much load. You know, as we think about a house and that radiant energy of the sun beating on that house, here's how much of that we expect to heat up the house to rise that temperature in the summertime, or conversely in the wintertime, here's how much loss that house is gonna have. And then they give you load sizes, and HVAC equipment is in British thermal units or BTUs. One candle, one match, if I were to strike a match and let that match burn, that's 1 BTU's worth of energy. And so, you know, a typical house on the air conditioning side might be something like 1,000 square feet per ton of air conditioning.
Right.
And a ton is 12,000 BTUs. So think of that 12,000 matches being burned. That's how much heating or cooling we're talking about, depending on the season, of course. And so having that actually designed by an engineer, by a smart trained person, and not just using a rule of thumb can make a really big difference, especially as we're coming back to this idea of comfort. Steve, let's switch gears a little bit and talk health. How does health intersect with comfort, and how do you define that?
So health is basically, people equate it to air quality, right? I mean, there are some other things we can talk about, but it is, you know, how healthy. We get a lot of people. We had a discussion earlier today where we were talking about a woman that came to you and says, you know, I have mold issues. I can't stand breathing it. And I'm very sensitive.
Yeah.
Multiple sensitivities to it. I get a lot of those calls where people are just simply saying, like, you know, my house is horrible. And, you know, if you remember back when we were talking about, you know, houses need to breathe, and I said, well, you can let the air come in arbitrarily, or we can bring the air in a dedicated fashion. And, you know, I always use our bodies as a really good example of what our houses should be doing. If you think about how our bodies take in air, the air goes in through a dedicated input.
That's right.
It's not leaking through my skin. It's not just kind of going in balls in my neck, right? It goes in a very dedicated input, and it goes to a filtration system immediately. And so the same with our houses. And, you know, I know you've probably seen us. We've talked about Zehnder and such, but there's tons of companies out there that have different types of filtration systems, air cleaning systems, ERVs, HRVs, depending on your climate. But you want to make sure that you're dedicating that amount of air that's coming in.
Yeah, that's right. I want to make mention of a visual that your old boss I've seen give before. Joe Stieberk has this great visual where he says, let's say if I took a coffee cup and I was almost done, I just had a little bit of coffee left, and think of the coffee as the pollutant. And he has this great catchphrase, which is dilution is not the solution to indoor pollution. So he takes the coffee cup in a clear glass and he pours water in and overfills the cup with water. And he does this for a while, and you realize, is the water perfectly clear? No. That coffee is being diluted, but it's still brown water. And so when we think about our houses, even though we've got fresh air, let's say, coming into our houses, even if we maybe throw open the windows on nice days, we need to remember that we shouldn't bring the pollutants into our house to begin with. And there's all kinds of pollutants that might be, for instance, where I am down here in Texas, we have a lot of moldy days. We also have a lot of high pollen days. I'm allergic to cedar pollen. And so when we have the cedar trees in Texas that are letting off their pollen, that's the time of the year that I know I typically am going to probably take an allergy medicine because I find that I'm very allergic to that. And so if we want to be healthy, we don't want to bring those pollutants into the house to begin with. The other thing, though, I think I've heard you talk about, Steve, is there's a lot of chemicals and sealants that are used during construction. Talk to us about that a little bit.
Yeah. So, I mean, the things we build with, there's a lot of people suggest that they have sensitivities to what we're building with. Again, the sealants and tapes, adhesives. I mean, as we make our building assemblies more complicated, we're relying more and more on things being taped together or sealed with some type of sealant to kind of elevate our air tightness in there. But with that becomes a lot of chemicals.
Yeah.
And so a lot of people are sensitive to that. And, the building industry is kind of, well, we'll just tape that up or we'll seal it up. I had the privilege actually of a few years ago, it was a large addition for a woman. And she said, I have a rule, no adhesives. So think about that for a second. Like, you can build my 1,800 square foot addition, no adhesives.
Wow.
Right?
That's not easy.
And it doesn't necessarily mean the stuff that's coming out of the tube on the job site. It means no plywood. All of our sheathing was board sheathing.
Interesting, yeah.
All of our floor joists, rafters, and studs were solid foam.
Yeah.
When I sent it to the structural engineer, he said, are you serious? And I said, yeah. He goes, do you know how much this is going to cost? I said, it doesn't matter. The client wants it. She knows.
Yeah.
And so it was a real experience to then have to work on a project where everything that you know and that we use and rely on daily all of a sudden was eliminated from the building list. And so, different people, different strokes. Some people say no spray foam in my house. And some people don't have a problem with it. Some people say that no adhesives or no tapes or we're sensitive. You have to check with your clients. It's certainly worth having a conversation there if you're a builder and or the architect to have that discussion. But, air quality doesn't stop once the building is built.
Mm-hmm.
We bring in a lot of stuff. And we bring in...
Meaning furniture,
carpet, things like that. Carpeting. All of these things that have chemicals on them for fire retardancy, for stain resistance. Right. And, I know a lot of these companies, as an architect, you could just say, hey, you bought it, live with it. That's the couch guy's problem, couch company's problem. But, if you're really diligent about your job, you want to suggest to your homeowners, hey, I know you went and you bought new furniture and stuff. I had one client that you've been to his house, Dan's, and he bought all his furniture and we had about 2.5 car garage. And he brought all his furniture in there, took all the plastic off it, and just let it kind of air out.
Sit in the garage
for like 2 weeks.
That's really smart.
Before he brought it in the house. And I got to tell you, I mean, when you take that plastic off, it's like, whoa.
Really smells.
The stuff that's in there because it's been encapsulated.
I mean, ultimately, that's the new car smell that we all equate to, hey, this car is brand new. It has this smell to it. That's off-gassing of materials. That's formaldehydes. That's all kinds of glues and sealants and chemicals. And funny enough, that car, if you leave that car in the sun with the windows down for 2 weeks, all of a sudden now that smell is going to go away. And so we want to be cautious about what we buy and what we bring in. And there are classes of things that will off-gas and be done, but there's also some things that will off-gas for the life of the product. And we're not going to get into that now, but for future study for you and for future series, we need to think about things like vinyl flooring that's well regarded by builders as something that will off-gas for the life of the product rather than having a short off-gas time and then it's okay. So you mentioned spray foam, for instance. If everything goes well on a spray foam install job, you can't be in there, you shouldn't be in there without a respirator on while they're spraying that spray foam. And it smells in the house that day that they're spraying it, but that off-gases really quickly. And those things that are off-gassing that are not good for you need to be flushed out of the house. You come back to that same house under construction a few days later, it doesn't smell, it's off-gassed and it's gone.
Yeah, a lot of those things, become somewhat inert over time. And I can attest to it. I've been in houses and I didn't put the respirator on, but if I walk through where they're spraying, the back of my throat gets itchy.
For sure.
Almost immediately.
Another one that we're familiar with for any of the older builders watching this is the oil-based paints that we used to spray all the time on the job sites. The painters would spray that, they'd have a mask on, but if you walked into the house, it would hit you like a ton of bricks.
Yeah.
That kind of oil paint smell, which is not good for you. But that, again, flashes off relatively quickly, and a day or two later, you don't smell it.
2 more points about health, because you bring up a good one with the oil paints that just made me think of, for all of you young builders out there that want to have a long-lasting life, right? You think about all the materials. Again, I'm just going to go back a little bit, but cement board is a material getting widely used today. We're coming up with a lot of materials that don't rot, don't deteriorate, don't dissolve. Well, guess what that means when that sawdust gets into your lungs? It doesn't rot. It doesn't dissolve.
Great point.
It sits there. I remember being on a job walking up and the guy was doing a cedar roof and him and all his guys were wearing masks. And I was like, can I just ask what the masks are? He goes, it's cedar. I go, I know, but I've never seen anybody wear a mask. He goes, well, you use cedar so it doesn't rot. What do you think happens when all that cedar sawdust gets in my lungs because I've been breathing it all day? It doesn't rot. It's just going to sit in my lungs for years. So, the health of the building, but the health of the guys building it is really important.
Yeah. Take that PPE seriously, right? You only get one set of ears, one set of eyes, and one pair of lungs while you're building those houses.
But the second point is, what do we bring in the house when we go in the house, right? And I've heard a very extremely respectable gentleman building scientist that I know, and he said, everybody's always worried about the air quality inside. He goes, the stuff that comes in at the bottom of your shoes, if you go walking around the house, is probably just as important as anything coming in through the filters and such. And it makes me think when I'm designing houses, like I always create entry areas where whether you want to or not, but it's available, people can take off their shoes, they can get stored, and then they can move in. We just had that discussion with a client this morning here when she was asking, well, do we really need this at the front entryway? And I said, well, it's a bench. You can require them to take off their shoes and it'll improve that air quality, as we get into the house.
That's a great point.
And move into there. So be careful of that, but also cleaners. Hey, look at this, man. This stuff will just peel the grease right off of my stove. Well, why do you think it does it that easy?
Yeah.
Because chances are is probably not that healthy for you.
There's something not so great in there.
Yeah. The things that work really, really well seem to not be very good for you.
Yeah. And that's true with air fresheners as well. And again, we don't want to I don't have the time to go into this in full depth, but in brief, most of the smelly things in your house are not great for you. And at my house, we don't use any air fresheners, air sprays in the bathroom. We don't have any plug-ins that make us smell all the time because none of that is good for you. Those are typically off-gassing VOCs or volatile organic compounds, and those smells are not good for you. So you don't need those. You don't want them. Be cautious about bringing them.
And there's websites out there now that you can go on and you can check VOC levels of different materials and all of that. I know we're going to be wrapping up here. The last point I want to make is the builder finishes the house. He's ready to turn it over to the homeowner. Joe and Susie homeowner are taking charge. As the builder, out of respect for your homeowners, you have to ensure that they understand the systems in there, that they know how to run the AC, the heating system, and most importantly, how to change the filter in their system. And if they don't want to do it, then you set up a maintenance cycle where you can come over, make money, and change their filters for them every 6 months or whatever the case is. But maintenance on the house is just as important as everything we do up until occupancy.
That's a great point. And let's actually take 2 minutes and run through filtration real quick. We've learned a lot about this when we went through the COVID crisis not too long ago. Everyone is talking about MERV ratings. If you're not familiar, when you buy filters for your, let's say your HVAC system, those filters have a MERV rating, MERV. Minimum efficiency reporting value, I believe, is what it stands for. Hopefully I got that right. And so we want a higher MERV rating. Higher means better filtration. MERV 11 is kind of generally regarded as what should be in most buildings these days. MERV 13 is even better. As we get up to like MERV 15, we're really close to HEPA quality, like what we use at hospitals for filtration. I have MERV 13 in my house. That's typically what I use for filtration on most of my houses I build. But as Steve said, it's really important to make sure that we're changing those filters and understanding the difference between units. Because, for instance, my dehumidifier at my house, I need to change that filter every 6 months. It's a real thin filter. Whereas the filter on my HVAC system is a 2-inch filter, and a lot of the houses I build have 4-inch filters. And the thicker filter means that there's more material inside that filter that can catch more particles, so we might be able to go a little bit longer. A lot of the systems that I use have a 1-year filter on the HVAC system. Mine in my house happen to be every 6 months that I need to change those. So we need to be thinking about how often to maintain those, because ultimately those particles that are in suspension in the air, if we can filter those out, now we don't worry about them going in our lungs. And so we're going to be cautious about what we bring into our houses. We're also going to be cautious about the filtration that's happening while we live in our houses.
You know, sorry, I know I can go on forever, but I do have just a couple of really quick points. For you builders out there that say, hey, yeah, air quality, comfort and stuff, we build a good house. Yeah, you probably don't know if you do or don't. But 2 discussions I always have with a client. Before we build the house and as we design it, the question is that window a fixed window? Do we make that operable? And I always get this, Steve, you don't understand. We love having our windows open. We open them all spring. We love to just have that breeze come in. I wait till the house is built. I give them about 6 months and I go over there and go, can we just kind of rehash that discussion that we had? Are you opening any windows? You know what, Steve, we should have made them more fixed. Dan, at his house, he will say, inside my house is the best environment I know. I don't want to leave. I don't want to open up the windows.
Yep.
The comfort and the air quality there. And to put it in perspective, Dan's house is a passive house that has an air tightness rating of about 0.44. And we've done 3 or 4 subsequent tests because he's good friends with the Energy Rater. And so over like the last 6 years, it's always been 4.4, 4.6, 4.5, somewhere in that range. And so, you know, it's a sample of 1, but it's testament that if you do it right, you get clients that are happy as a clam.
We're going to go over blower door testing in a future episode, by the way, so stay tuned for more on that. Steve, let's wrap this up. We're on that 3rd rung of the ladder. You want to, you think you could summarize what we talked about today?
Yeah. So again, it's about control, right? If I want to develop comfort, I have to build a really good envelope. Then I have to have the right people sizing my equipment. And then that equipment has to be installed properly and commissioned properly. We didn't mention that, but it needs to be commissioned properly. As far as health goes, the things we build with, the things that we bring into our house, and the things that piggyback us going in and out of our house. Think about it all the time. Every time you're going in there, take your shoes off, walk around in your socks, keep that house clean.
I love it. And I'll end with that quote that I used earlier from Joe Stebrick. Dilution is not the solution to indoor pollution. I love that. There's so much weight and meat to those words.
This episode of Build Science 101 brought to you by our friends at Polyguard. Now this may be a name that you don't know because in the past I've made a lot of videos. In fact, they're one of our very first sponsors. You've heard me talk about Polywall and you've seen me make a lot of videos about Alumaflash and Blue Barrier. Polyguard is the parent company and they've done a bit of a rebrand. They've sunsetted that Polywall name as a brand family, and some of the individual product names are changing as well. Same products, same great company. They've been around for 70 years and they make some really bomber products. Steve, have you used any of the Polyguard products before?
You know, I was just recently introduced to them, Build Show Build Boston. Our whole foundation system is coated with the Polyguard products. And the thing that I like about it the most is it's a systems approach to waterproofing, right? They could have very easily just made the waterproofing and said, hey, here's a great waterproofing, have at it. But they provided a dimple mat. And it's not a dimple mat. They provided 2 different dimple mats because they understand that the water accumulation at the bottom might be greater than the water accumulation at the top. Right. So they have a totally different mat. They have their Blue Barrier product for that cold joint between the wall and the footing. So it's really great when there's companies out there that understand that there's a differentiation in risk, right, between the wall and that cold joint, and that they develop products accordingly, create the system that as an architect and a builder, we can put faith in. And you know, a basement is not something you want to dig up a year later to try and find a leak. So you have to put a system in there that we trust and we believe in, and one that's going to work. And they have their barrier system, but that dimple mat offers that water management on the outside of it, so it doesn't even really get challenged.
Yeah, and this really ties in perfectly, Steve, with our Build Science 101 series. Steve and I have been talking about how water is the #1 enemy, the #1 killer of buildings, whether that's groundwater, rainwater, water that splashes back against your house because you didn't put gutters on, whatever. So when we talk about these products that Polyguard make, these are really bomber products that are going to protect your house for the lifetime. Quick story with these guys. About a dozen years ago, when I kind of stopped using house wrap, I realized I needed to up my game. I ran across this product called Alumaflash, now UV240. Peel and stick, aluminum facer. I recognized that another really good builder in town was using it. Here we are more than a decade later. Every well-built custom home in my town is wrapped with this silver facing, which is the Polyguard product. The builders that are doing the really good products here in the South recognize this is the absolute best, most bomber way to build our house. So that being said, big thanks to Polyguard for sponsoring today's video. All kinds of products that we didn't even get to mention. Go check out more at polyguard.com.
Guys, we just finished up number 3. Stay tuned for episode 4. Otherwise, we'll see you next time on The Build Show.